morning. Good morning. Been away from stream for a minute. Where are you guys? The main reason for that is because I've been working on my proposal. So in a couple of streams, maybe we'll work on the presentation and basically developing a study guide for the um, in-person examination that I'm going to have to go through eventually. Hopefully that'll be done before the year is out if people are available. I'm kind of doing this a little bit last minute, unfortunately, but you know. All right, so today we are going to set up AlphaFold on the supercomputer. So the first thing we need to do is open up a session here. So we're going to do it on Narval. All right. So for some reason on Narval, you have to download the databases, which I think they all went through, but I'm not 100% sure. So we're going to have to check that. I've ran it once before, but if you don't touch these files after some period of time, they end up deleting themselves. So basically what we're going to have to do is, where are we at? Here. So this was the fetch databases.sh. So let's look at this. I can just do that. 3 GitHub. So let's look at this .sh script and see what we're dealing with. Refs head main. Oh, it's right here. So I'm guessing we're fetching all of these here. So do we have all of those, or I think so. Man, we could just try and run it and see what happens. Kind of more leaning towards that because I was having some trouble like getting all of these fully downloaded because they're literally like hundreds of gigs. So I shouldn't have opened that. All right. It's kind of a pain to work with, to be honest. So download the databases. Okay. Running AlphaFold in stages. Splitting the CPU only data pipeline from model inference, which requires a GPU to optimize costs and resources. Okay. All right. So I guess we need to get this. So where should we run this? I guess within the AlphaFold directory. So I'll do touch. AlphaFold 3 data.sh. Why is it taking so long? All right. So we don't need that. We don't want all of that. Just want like 10 minutes maybe. So we need to basically see if all of this works. Which I do remember having to do something like, I think it was like the run AlphaFold command or something. Let's go ahead and copy this over. Again, we can just do this. Set it to, probably this would be like 20 minutes maybe. I wish I could give you like an example job. So does this require input? Yeah, it does. Okay, so what we need to do is input just a directory. Looks like it. Hmm. So let's make an input and output directory. Okay. Edit with proper arguments and run your commands. So let's uncomment this. All right, chmod plus x. My hands are so cold. Turn the heat on. Can't type. S batch, AlphaFold. This is inference. Let's see what happens there. In the meantime, oh, there we go. Okay. Specifying input files. Okay. One of two ways. Use a JSON path following, or use the input directory. Okay, so that's what we're doing here, looks like. Followed by the path to the, okay, so regardless, we have to do a path to a JSON file. Custom JSON formatting, differing from AlphaFold server JSON input format. See below for more information. RNA, custom MSA, custom structural templates for protein chains, ligands using smiles, covalent bond entities. So this actually might be nice for the rings there, just specifying a covalent bond. I wonder if I could do that. We can provide a converter which automatically detects input JSON, denoted dialectic in the converter code. The converter denotes server JSON as an AlphaFold server. The JSON format defined here in AlphaFold 3 code base. If detected, input, and the converter will translate that into JSON format AlphaFold 3. Okay, so I think what this is saying is from like an AlphaFold 3 prediction from the server, it'll automatically detect that it is from the server, and then you can run it here, which is pretty neat. That actually might be useful for like specify, well, you can't really specify like custom. Well, actually, no, this might actually help us. Hey, how's it going? What you up to? I think it's all right. So I think what this is talking about. Still sick? Yeah, I am a little sick. Not really though. Did I say I was sick last time? Oh, so yeah, this is what it's talking about here. Dialect. Okay, just chilling at work. Nice. Work going okay? Okay, so we're running. It took a lot less time than I thought. It's gonna be like no input or something. But did it work? I think so far so good, y'all. Busy. It sucks in the moment, but then at the end, you realize that like you got through it a lot quicker, you know? Like honestly, when it's a slow day is kind of when it sucks. So I don't know if this worked or not. Seems like it did. So I guess let's just go to inference and into the that directory. We could just paste this honestly and see what happens. I'm working on setting up AlphaFold on the supercomputer. Um, AlphaFold now has the capacity to take like custom ligands and covalent bonds and stuff. So I need to predict some structures with some custom modifications because the server doesn't allow for that. So that's what we're doing. We're just trying to see if it'll work. Yeah, so far it's not really giving me that much trouble, but I don't want to. I already spoke too soon. Because I know this is gonna probably be annoying. But all right, so I think what this means here, according to the docs, so this will just work, I think. So user CCD is the strings, it's the smile string, so we might have to use that. Still struggling with bond angles? What do you mean? Uh, okay, so there's different versions of the JSON. Okay, 3. PTM. PTM type. Modifications, list protein. An optional list of each modification specified using CCD code and one base residue position. In the example, we see that the first residue won't be a proline, but instead HY3. What is HY3? 2mg. Is that, I guess that's the CCD code? Okay, so ED smiles. I think they changed this since the last time I read it. MSA pairing, structural templates, that's cool. Bonds, okay, I think manually specified covalent bonds. This is intended for modeling covalent ligands. So this is residue 1 for ligand simply set to edit. This is a string given within the residue. Yeah, this should be super easy, I think. Yeah. So I just need to draw a covalent bond between. The only thing is I'll probably need to change the residue to a dehydrated one. So that's going to be annoying, I think, but we'll get there when we get there. So for now, let's go to, this was inference. Or no, what do we run? Wait, what's the first thing we do? Oh, so dispatch data. Wait until then submit the second stage. Okay, so the second stage is inference. So what did I do? Oh, I did the inference first. So that's wrong. I need to do data. All right, so this is just specifying an input directory. So I think I can just do like input.json here, and this will work. Let's look at the so when it says submitting a job, these are just about input files. Output directory structure. I don't think we really care about that stuff. I'd say we just run it. Oh, okay. Followed by the path. To a directory of JSON files. Okay. So, never mind. I think we just leave it like this, actually. Okay, so let's chmod +x Please note that slow memory. All right, let's see if this runs. In the meantime, one thing that we can do is set up a simulation for a homolog of the protein that I'm studying. So specifically, I want to do something, I forgot. Maybe it was BHT, I want to say. Yeah, it was this one. Because this one doesn't have a zinc binding site. You teach chem, right? Yeah, I do. You got some questions for me? So, do we want to start the simulation here? Let's look at the ring formation. So there's the phos. So there's supposed to be a ring between this doesn't have it. Where's the other paper? I meant to do this one too, actually. THS. There we go. All right, so basically I work on an enzyme that catalyzes the formation of thioether rings on a peptide. So we're trying to look at these different homologs here. The one that I specifically work on is HAL A2. And the idea is basically like you look across similar proteins that do, or similar enzymes that do the same thing. But we want to identify something that's like consistent across them to maybe identify what the mechanism would be. So BHTA2, initially I thought like ring B was, well, we know actually from some experiments that we've done that ring B is kind of the first to form out of all of these, which is kind of strange because the order of dehydrations occurs sequentially from N to C terminus. So it's odd that like B would be the first to form. Um, so it implies that there's like some sort of prerequisite binding geometry influenced by ring B formation to either like help ring A formation or like maybe dehydrate later residues or something like that. But this one doesn't have a ring B, and it doesn't have the zinc binding site, which is believed to um, help catalyze the formation of these rings. So I think this is like an interesting thing to study or simulate first, BHT. So the ring is going to form STPAC. So it should be STPAC. Yeah, right there. So here is the phosphorylated prediction. So at this point, this is like the second dehydration. There's our cysteine. So let's take a look at all of these here. Could look at the unmodified too. And try to identify like what would be like a good starting geometry. So this one's serine getting dehydrated. I assume after the second dehydration is when serine will form the ring. Every time I say serine, Siri freaks out because it thinks I'm talking to her. I don't know. I think this is probably as good as prediction as any right there. All right, so let's see if this. Okay, so did that just run? We're kind of doing like multiple things at once right now. Cannot open file. No such file or directory. Okay. Cannot create directory. File exists. No such file. Okay, so I think here we need to remove the output because it's going to create that on the fly, seems like. And then we need to get this run alphafold.py, which should be present here. Now, hopefully this is the right version. Because this is, where are we at? What version are we in? This is all modified. So this is 3.0.1. So is that going to be different from the one that we're trying to use on the supercomputer? Maybe it has like a message about that. Oh, okay. No, we got 3.0.1. Nice. So this should work then. So where does this need to be? Just in here. What? I copied this. Good Lord. I goofed. What's that? Alright. Alright, so we want to touch. Control C. Thank you. Alright, and then we're going to copy this code here to this. Pretty long code, 1,000 lines. Yeah, it's pretty crazy. A lot of stuff going on. Alright, so we should be able to run data again. That's the first step, right? Alright, let's see if that works. So if we're going to start a new simulation, I gotta go pretty soon. I'll be back though. We want to go to search hell. PHMD I think just open our code from here. Yeah. So I guess we can do like mkdir homologs. We could do lan m, and that would be yeah, I guess lan m2. How do I have? That'd be unmodified, modified, or you could do lan m1 and m2, I think. I think that's a better way to separate them out. Lan m2. Um, so, and then within lan m2, you have to do bh, bh, and bhtm2. Okay. And then from there, we can add our starter files. So these are just files that I've created that are like general purpose, can be applied to any simulation. So we just copy these over basically. All right. So from here, and I think, did I already specify the, yeah, nice. So I already specified the titratable residues that I wanted. So that cuts the work down a little bit. But now I just want like a structure to use. So I'm guessing this one is probably fine. So we can go into here, open, and then open Pymol, I guess. Just to take a look at it. Oh, we also probably need to do H++. To help out with like the pronation state and stuff. What was my thing? Give me 1 second. I'm gonna black out my screen for. Okay, I got it. All right. Process a structure. All right, so we'll do that in a second. I guess this one. So this looks like Hallam too, but it's different. So here's the peptide. Click blue. Okay, so off the bat, what is this? Serine? I thought there was a TPO residue. God, serine. So we don't want this one actually. going to go to modified plan to STPAC. So we want to go probably 34. Look at those. There we go. All right, so some of these are clearly wrong because like the zinc should not be over there. I like this one because there's a lot of secondary structure in the peptide itself as well as like the interdomain region. Not that one. Really, any of these will do. And does this one have better coordination to the zinc? So I think likely the zinc is going to carry this, or the peptide's going to carry this zinc off. It doesn't really matter, honestly. We'll just do this one. I think in AlphaFold, the first prediction is the highest confidence one. So, all right, so we could just straight up save this. And then save it as PDB, desktop, research, Helm 2, there, homologs, LAN M2, BHM2. We could just do like start a PDB, right? All right, system. Ooh, what happened here? Of course. Oh, right, okay. Please note that standard alpha are only available if you do not agree to these terms. So do I need to put the stuff somewhere? Maybe here it defines a file path to the I have the weights somewhere. Right here, AlphaFold 3 bin .zst. So do they have this here? Okay, well, where do I specify the weights then? Oh, maybe in the input? I think that's what it was. Is it model directory? Uh, docs, input. Installation. Yeah, I think it has to be model directory, I want to say. Can we load it as what it says? Like just the ZST file? Um, uh, so I guess I'll just copy this. And just plop this in here. Like that. What does Slim say? All right. Small BFDZ value. What does that mean? Got an unexpected keyword argument. It did create an output. Um, Maybe just do this. And why do I need any of this stuff? But I don't know. All right, so while I was copying over, let's just pivot back to here. Did we save this? I'm not sure. Yeah, we did start. All right, so now we can load the start file. Which should be here. So one thing we need to do actually with the start files, we need to clean it up a bit by removing like ligands and stuff. So I think it'll be all right if we just put a hashtag in front of this crap. It might not complain. We can delete the connect records as well. This should be fine. Browse. Oh, we gotta do it the long way. So we want to go to homologs, PhD. Start here. Process file. Are you gonna complain? 30 minutes. Salinity 0.10, I think. This doesn't matter. 7. Well, actually 6.5 would be fine. No, that's more acidic. Just do 7. What pH do I run it, actually? Do we even define pH? I thought we did. Somewhere. Okay, 7.5. Yeah. No. Process. Let's see what it does. Okay, this is still taking forever. It's only like a gig. What else can we do? I guess we can convert this into a command. So I'll just ask ChatGPT to do that for me. Do I have it pulled up? Read the residues I want as titratable. I can't spell. Convert these residue numbers into a command I can run like this one. One of the best use cases for AI is just like getting rid of this mundane crap like this. So there should be 50 here. Oh. Bro, how long does this take, really? God, it's probably because I'm streaming while I'm doing this too. It's your fault. It's your fault. Um, so let's look at the documentation some more. The correct handling of two-letter atoms and small strings. We don't have any bromines and chlorines to worry about, so um, so what about like custom residues? To manually specify covalent bonds, this is intended for modeling. Hmm, okay. Okay. So I remember doing this, and this was like such a pain in the ass to do. Which illustrates, okay, naphthalene. Hmm. Can we generate these on the fly? Please take longer. I think it's almost done. What did two 740? Oh, I need to say my mistake. For each of the peptide residues, we need to add 876 to it. Make sure the residue numbers are in sequential order. Found that out the hard way. All right, so it's uploaded. So now I think we can run data, I want to say. Let's see if that works. I know ChatGPT kind of sucks at math sometimes, so I might have to double check that. 876. Just do like an easy one. So plus 37. That'd be 740. Or no, would that be 913? 7 plus 6, 3, 1. Yeah. All right, I think it worked. So this will be our new command here. How many residues are there in total? All right, ooh, we got done there, so that's good. So what we want is this one. We could just drop this into here. Go look at it. Looks fine to me. So one thing we want to do is like open, and then we can drag this onto here and see how close they are. Yeah, it's literally like spot on. Okay. So there's a couple of names that are changed. HIP, for instance, on some of them. So at this point, what we want to do is basically remove this. Action, remove atoms. So we're just left with these here. And then we should be able to save this as a new PDB. We could just rename this as start underscore H++ modified. Okay, so this will be pretty much our input. We can delete all this connect BS, which there's a lot of, a ridiculous amount of. Like, why? All right, where's the peptide? Right here. We have our peptide, our zinc, our ADP. So we'll copy that. Place this at the end here. So I think, yeah, these come last actually. All right. So we need to change this to ATP. This should be, I forgot what this should be. It's like ZDB or ZNB maybe. And then this should be ZN. I think that's what you do. And then we need to change these names here. So I could do this by hand, but I think I have a script for this, which is here. But I want to create a new one, honestly. Oh, I might be too lazy to automate. Let me see how bad this feels first. That already feels bad. I don't feel like doing that. So I just want like a simple script. Okay, great. I would like a simple script that can take as input a comma separated list of residue numbers and change the names of them to titratable names. GLU and GLH, GLU, GLH should be GL4. HIE and HID and HIS should be HIP. ASP, ASH should be AS4. What are the other ones? This should be it. CYM. Oh, I guess LYN too. LYN. And CYM. I don't think CYX is going to be anything. What even is CYX? It's for like crosslinks. Note that the peptide will have to directly follow the enzyme sequence so that the numbers will align. Right now, the peptide starts at 1 end. So we need to account for this in the code, please. I just want to change the residue names. Write this code in full. All right. So this got done, it seems. So we got Okay, we still got the same error as last time. What? Why is it giving me this BS? Let's run it one more time. Remove all the slurms. Invalid user? What? Never seen that before. Oh, I could do that though? I have no name. What the hell? Did I just get banned? Well, I'm gonna stream. We're gonna leave off there on a cliffhanger. All right, see you guys.